Okay, so we were just talking about polar and nonpolar, and my picture of the person is really bad here, but there's supposed to be a guy with a fishing pole, and of course you only fish in water, and so polar is what water is. I don't know if that helps you, but I thought it was pretty smart. Okay, number 5. Distinguish between the solubility of a polar and a nonpolar molecule with water. Whoops. Okay, so solubility means will it dissolve in water or not. So remember, water is polar. Anything that's polar will dissolve in water. So that doesn't mean dissociate or come apart necessarily. Why does it do this? I think I'm pressing a button or something that I'm not supposed to be pressing. Okay, so anyway, anything that is polar will dissolve in water, and anything that's nonpolar separates in water. I hope you can read my messy writing. In other words, stuff that's polar mixes with water, and stuff that's nonpolar does not mix with water. Does not mix with water. So that was the lab we did where we had wax and butter and oil, and they separated because they're nonpolar. And then we had salt and sugar, and they mixed with water because they're polar or ions. Okay, number 6. What's a hydrogen bond, and is it weak or strong? So a hydrogen bond is a bond that's between a hydrogen atom of one molecule and something else of either another molecule, or it could be a really big molecule, and it could be two parts of the same molecule. But anyway, this is a covalent bond. So the covalent bonds are sharing electrons there and there. Hydrogen bond, they're not sharing electrons. It's just that this side is slightly positive, this side is slightly negative, and negatives and positives attract. So that would be your hydrogen bond right in there. Just a very weak bond. You find it in DNA at the part where it unzips. So everything I've drawn so far is covalently bonded. And right here, between this side and that side, this thing right here, that's a hydrogen bond. Holds DNA together, but it helps DNA, it allows DNA to unzip. So DNA can look like this. And this part can be unzipped so it can be read, so you can use the DNA to make proteins, or maybe so you can replicate the DNA. Know which bonds form in water and which form between water and molecules. Which form in water and... I have that written the wrong way, but what I'm getting at is this thing is a covalent bond and that thing is a hydrogen bond. I'll have to fix that before I give that to you guys. Okay, number 8. Distinguish between acids and bases, which has more hydrogen ions and which has more hydroxide ions. An acid is anything that releases a hydrogen ion when it's in water. And a base is anything that releases an OH when it's in water. So an acid, for example, this thing is an acid, and I wouldn't expect you to know that until I draw the products. The products are the hydrogen ion and the chlorine ion. Here's hydrogen. By definition, an acid is something that releases hydrogen. So, for example, if your stomach, if you throw up, you'll notice that the puke is burning your throat. That's the stuff that's in your stomach all the time. So your stomach always has a whole lot of these hydrogen ions in it. A base doesn't release hydrogen ions. A base is something like this, NaOH. We put it in water. The sodium separates from the hydroxide ion. And so a base, by the definition that we're using, releases hydroxide ions. And here you are. So this thing is a base, and this thing is an acid. Which has more hydrogen ions? That would be an acid. And which has hydroxide ions? That's a base. Be able to... Ooh, they stayed. That's not good. Be able to distinguish between weak and strong acids and weak and strong bases given a pH. Okay, so here's all you have to know. Here's the pH scale. Starts at 0, ends at 14. The number in the middle is 7. And now what you have to do is sing your alphabet song. A, B, C, D, and then you can be done, because A is for acid and B is for base. Anything from 0 till almost 7 is an acid. Anything bigger than 7 to 14 is a base. Anything near 7 is weak. So if I give you two solutions, one is pH 1 and one is pH 6, one would be the stronger acid, and 6 would be the weaker acid. You know they're both, whoops, you know they're both acids because they're on this side of the number 7. If I give you pH, let's say 8 and 9, well, first of all, they're both bases. The weaker one is the one closer to 7. So this one would be a weak base, and that one would be a strong base, or at least a stronger base. What elements are found in living things? Well, lots of elements, but the ones that I want you to know are chomps. Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. People tend to have a lot of calcium in them too, and a few other elements, but those are the main ones that I want you to know. That's what all your macromolecules are made out of. How are all polymers made? This question's a little bit different for honors and CP. For CP, I want you to know polymers are made by putting together monomers. So let me write that in. Polymers are made by putting together monomers. If you're in the honors class, then I want you to know it's also by, let's see, you're making it, so that's dehydration synthesis. And so what that means is you have something like, I don't know, something like a sugar maybe, and it's got an OH sticking off of it. And here's another sugar, and they have lots of OHs hanging off of them, but I'm lazy and I'm not drawing them all in. When you put these together, you're putting monomers together to make a dimer, or you can keep doing that and make a polymer. If you take out the OH here and the H here, you would make water, and you can bond this carbon together with that oxygen. So it would end up looking, this is a bad drawing, but here's the carbon, and it's not connected to the O anymore. It's going to be connected to that O. And that O is, of course, still connected to that carbon. So it would look like this. So it's dehydration synthesis. How are all polymers broken down? And so for my CP kids, what I want you to know is they're broken down by taking monomers off. Or you can just break them in half and keep breaking and breaking. But you would be breaking, let's draw a picture of this. If you have a bunch of stuff like, this is weird, it's not showing up. Ah, where's my cursor? Boo. I have no idea where I am. Okay. For some reason my cursor's not showing up, so pretend that I didn't have all those stray marks. So in other words, you're breaking this bond right here. For the honors folks, what I want you to know is right, blah, I don't know where my thing is. Okay, right here, you'd be putting on an OH, and if this is an O, then you'd be putting an H onto that. So you'd be putting water into the system. So if you put water in to break stuff apart, right here you would put on an OH, and then the O from above will still be there, and you're going to put an H onto this. So that H and the OH you got from your water, and that's called hydrolysis. For my CP kids, you don't need to know any of that. You just need to know that the stuff I typed, polymers are made by putting together monomers, and polymers are broken down by taking monomers off. So my CP kids just need to know this answer, and my honors kids need to know dehydration synthesis and hydrolysis. What's an organic molecule? That's anything that has at least 2 carbons. 2 or more carbons. And so the organic molecules we studied were carbs, lipids, proteins, and nucleic acids. And I think this is a good place for us to break.